Hello. So this video is a follow-up to the previous video that I made talking about AI and its use in educational contexts, and specifically talking about SkellyBot, which is a AI chatbot, Discord bot that I have made and been using in my teaching responsibilities for the past 4 semesters, give or take. And for context, my name is Jonathan Samir Mathis. I am a professor of neuroscience at Northeastern University in Boston and the president, founder of the FreeMoCat Foundation, which is a 501c3 certified public charity dedicated to the development, dissemination of high technology to the widest possible audience. So the last video garnered a couple of questions from some relevant parties that I, similar to the last time, kind of sat down to try to answer via text and kind of like quickly realized that there was a lot of kind of conceptual stuff folded into the questions that was really important to kind of like get right, sort of like to make sure that we all are using terms and that in the right kind of way in order to be able to give a good answer to the questions that were asked. So I'm recording this video to try to get on the same page about some of these topics and also to provide answers to the questions that were originally asked. They sort of long and short are sort of on the screen right here, paraphrased obviously from the actual questions that were asked. And let's get into it. So the first question that was asked, arguably or inarguably, this question is the reason why this is a video response and not a text response, because it's a very big and a very good question, which is basically, how does SkellyBot differ in core functionality from things like ChatGPT and GPT-4, etc. And the reason why this is an interesting and good and kind of hard to answer question is because it involves at least the potential for a conflation that I've seen be very common in like the sort of standard human understanding of the current landscape of AI and large language models and things like that. And so there's an important distinction that I want to make here and make sure that it's sort of clarified about the difference between what I'm just going to call in this context the model that's related to the AI, so specifically the large language model, and the user interface that we use to interact with that model. So we can start this out by looking at the website called ChatGPT, which represents a user interface. So ChatGPT is fundamentally a website, and the website represents a particular user interface, which has a couple of important features. So mostly what this is, aside from the history and a couple other bells and whistles, is it's a thing at the bottom that allows me to put in text saying, "Hi, how are you?" And I push enter, control enter, and it gives me a response from a model that we would call, it calls it ChatGPT 4.0. It's funny, I actually didn't realize that that's what they call it on this site, which is part of the concern. So this is an interface. This website represents a particular user interface for interacting with the large language model that should be called GPT 4.0, which if we go over here to platform.openai, which is basically a little bit behind the scenes, that's what that model is called. So this list here represents the available large language models that ChatGPT, that OpenAI hosts in order to allow you to interact with them. And the way that basically works under the hood is that this user interface website is designed so that when I say, "Hi, how are you?" and then I push the send button, this blob of text is sent to a server, an API server. And this API server basically is a big, powerful computer that lives at some data farm somewhere that OpenAI and Microsoft have access to. And the blob of text representing the question, so "Hi, how are you?" gets sent off to this server. It goes through a particular thing called an endpoint, and then is sent into some system of complicated tubes, and then funneled into the actual large language model, LLM, that in this particular case, because of how this is set up, the large language model is called GPT-4o. And this thing right here, this LLM, large language model named GPT-4o, that's the actual engine that's driving the AI. The website itself is nothing particularly special. It's simply a chat window, which we've had chat windows for about as long as we've had computers and browsers. And this large language model here, this is sort of the magical beast that lives within it that allows us to do things like say, what is the cerebellum, and get something that resembles an intelligent answer. So these language models here, so GPT-4o is the sort of the close to the latest one that OpenAI has offered. The sort of GPT-4 was kind of like the big one that showed up that sort of changed a lot of the game in terms of natural language processing and just the technology that we now call AI. But there's many, many others of these, both in terms of OpenAI's capacities and also there's other models from other sources. For example, this one is called Claude, made by Anthropic, and hi, how are you? You can see this is a different user interface, roughly the same idea, same basic functionality. I guess I should finish this picture over here. So I put words into a box, I push send, it goes to some server somewhere and gets funneled through whatever backend they have. It goes into a large language model. In this case, it's not called GPT-4, it's called Claude. Claude, what is this one specifically, like Sonnet or something like that? I don't know, whatever it is. And then it goes through the AI magic, which this is, details are sort of obviously complicated, but in the end, it's a neural network. And it's a neural network that has been trained on a massive amount of linguistic data so that it can do the thing that neural networks do, which is to map inputs to outputs. And in this case, what these large language models do, they're generally trained on some version of a transformer, and they have the ability to take in linguistic text and spit out linguistic text that goes back to the endpoint, back to the user interface, and then gets sort of placed into the chat window, and then we can sort of repeat that process. And so the point that I'm trying to make here is that whether you're talking to GPT-4o on chatgpt.com, whether you're talking to Claude 3.5 Sonnet or whatever on the Anthropic website, or even if you want to use one of these smaller local models that can run on your own machine. So this is Llama 3.1, and it's running entirely on my own machine. I can say, hi, how are you? It gives a fast, not particularly intelligent response. What's the cerebellum? These are all basically roughly the same thing. In this particular case where I'm running it locally, it's a little bit bean-shaped structure, kind of. Get out of here. In this one, it's a little bit different because instead of being a nicely well-formed website, it's just a simple terminal window. And instead of going to some external server at some remote location, it's going to my local tower, which is under the desk. But in the end, it's still the same basic idea where I give it some text, it sends it through the neural network representing the large language model, and it gives me a response. And so that's the basic structure. And I think that it's very important that we understand and sort of maintain awareness of this separation between the model, LLM, what I would call the core technology, and the kinds of user interfaces that we built to interact with that core technology, and how both of those things sort of interact importantly with like the use case, like the desideratum of the tools that you're building, like the thing that you're trying to solve, the problem that you're trying to fix by building whatever tool it is. So for example, you could imagine the LLM as like an internal combustion engine. And then from that kind of core technology, you can build a lot of useful things. So for example, you can build a car, but you could also take that same engine, configure the interface around it differently, and build an airplane. You could also put the propeller on the back and improve a sailboat into now it's a motorboat. And even noticing now, all of these three things, although they're quite different from each other, are all related to transportation. But you could also take that same LLM, which in this metaphor is a internal combustion engine, and transform it into a pump that pumps water from a river and use it for irrigation. So all of these things are using the same core technology of an internal combustion engine, but the way that it's being configured and the interface around it allows it to fit a very wide range of potential niches and use cases. And I think that it's important to sort of keep that sort of separation in mind as we're in this case, because I think it's really easy to kind of think about what we are doing here in this present moment as we are trying to figure out what we can do with AI, to think of it as something like we're building specific tools for specific purposes. And I think that the much more, we have to think about things in that way, but I think it's much better to think of it less in terms of like the specific use cases that come around, and more in terms of the different types of things that can be configured and developed with the core technology that we have just discovered collectively as a species. And furthermore, I think that it's doubly so important for us to keep these kinds of distinctions between interfaces and the core model technology clean and clear in our minds, because we are, in this particular context, talking about developing tools for using AI in educational contexts. And as I believe I said before, and I will definitely say again, I think that it's absolutely essential as we're building these tools to try to make sure that they are autogogical in nature, meaning that the tool teaches you how the tool works. And fundamental to the design process and the design philosophy has to be a drive to make sure that as the users, in this case students, just end users in general, are utilizing the tools that we built, that they are also gaining an understanding about the fundamental aspects and the background and the nature of how that technology is operating. Now, every student may not want to dive all the way down to the bottom of that ocean, but it should fundamentally be available to them, and part of the design philosophy should be getting them clear about some of these distinctions. And with that in mind, I want to I'm going to belabor this point just one layer deeper before I go back and actually talk about the topic that we're actually here for. And I'm going to do that by talking about this sort of extra layer of complexity around here, around the concept of an agent. So if you recall, the basic AI interaction is some blob of input text is shoved into the large language model, of which there are types known, for example, GPT-4, and an output text comes out. And there are a lot of different user interfaces and different mechanisms, different types of language models, and different ways of engaging in this basic behavior. But at its core, this is the fundamental technology of AI in 2024. And no matter what anybody tells you, we do not fully understand how this works. We do not fully understand what is going on in this box. We know how to make it. We don't know how it works. That doesn't mean we can't build stuff out of it. So this basic interaction is very powerful. It can do a lot of things. And all the sort of little samples I was showing before is basically instances of this. However, this basic interaction is limited. For example, if you asked it a question, that's what I was going to say. Clarifying, this input text could be anything. It could, in the case of a simple chatbot, it could be something like a question, like what is the cerebellum? It could say, what's a dog? This thing chugs on it and says, oh, it's the fuzzy thing with ears and teeth that says bark. It could be the transcript records of a student along with a list of course descriptions and instructions saying recommend classes that the student might enjoy, or it could be a transcript of the student with a degree description and say what is this student missing and how might these classes fill it in. As long as the basic interaction is blob of language in, blob of language out, that's what we're going to call the basic interaction. But there are many cases where this is not sufficient. So for example, if I said, hey, is today a good day to go on a picnic? The basic interaction here would be insufficient for that task because there's a lot of information that it doesn't have available. It knows what a picnic is. It knows what conditions are for a good picnic because that's just a part of its data set, but it doesn't know where I live and it doesn't know what the weather is. So in order to expand the capacities of language models and LLMs beyond this basic interaction, there are various ways to add tools to this basic workflow. And I'm going to call the combination of a large language model with some set of tools, I'm going to call that an agent. This is a place where some of the language kind of breaks down because, UI, that's a standard term. LLM, that's a standard term defined to some level of specificity. But what I'm calling an agent is called different things in other places. Specifically, for example, in OpenAI, they call them assistants. In LangChain, they call them agents here. There's other things where they call them tools. It's a whole, there's all sorts of names that you could put for language models plus tools. I'm going to call them agents. The lack of specificity in the naming is kind of part of a point, which I promise I will get to in a moment. And so generally speaking, a tool is anything that the agent can, call this agent, anything that the agent can use to get information that is outside of its original training set. So generally speaking, an agent or an agentic like model, or not model, whatever it is pretty much always going to involve more than one internal call to a large language model. They don't have to be the same language model. It's actually kind of common to use like a small, fast one for certain tasks and a big, heavy one for other tasks. So for example, that question of is it a good day for a picnic might go into this agent, and the first LLM call will include the question and sort of a general question of what kind of information do I need to answer this query. And then it would say, well, you need to know what a picnic is, which we already have because of it's a part of the training data somehow. But we also need to know the location. We need to know the weather. And so there might be another step that says what tools do we need to use to get that information? And then it could use a tool to sort of query location services and say, oh, hey, you're in Boston. And then it could feed that information into a API call to like weather.com and say, oh, it's a sunny day in Boston, fill in this information, and then feed that into another LLM call that includes the original question plus the information. So this LLM would see the human asked, is it a good day for a picnic? They are in Boston. It is sunny. Then this LLM can say, yeah, it's sunny in Boston. So yes, it is a good day for a picnic. And so that's roughly speaking how you can expand the behavior and the capacities of these things beyond the simple input LLM output interaction. But also notice that this is fully decomposable into instances of that. So for example, in the thing I said before, where this interaction could be a student's transcript and a list of the current course offerings, and a description of instructions saying recommend some classes the student might like. You could just get that information, copy paste it into the chat window, push enter, and then get an output. Or you could build a kind of agentic system where the student could just show up and say, hey, I have an elective slot. What classes do you think I might like? And then there could be a tool that would go onto an LMS and pull that student's transcript and maybe some like personal statement and previous conversations and sort of other information about that student, along with another query that says, give me the current course offerings for the next semester, for the next couple of semesters, and then combine those into the question and say, hey, maybe you would like to take, this art class and this, math class or whatever it would want to be. And so on a fundamental level, the activity of this agent, which is LLM plus tools, is in the output step indistinguishable from just copy pasting that text information into the original chatbot. And so oftentimes more complex AI applications have this kind of plumbing feel where there's just a lot of different ways of splitting apart the initial input, pulling information from other places, and composing it into a prompt that sort of gets answered by one or more calls to the large language model. A last thing I would mention, like a very important tool that happens, is what's called a vector store, which can be basically a massive, sort of an unconstrainedly large store of linguistic information, like the text of every textbook written in the past 20 years, or every conversation that any student has had in any class, or all of the papers of all of the professors that teach at this school. And that information can be pulled apart and processed in a wide variety of ways, which would be a whole other long and interesting video, into a vector store of information that can be queried on the basis of the original question and then composed into things. So you can say, oh, actually, you have mentioned an interest in birds at some point, and there's this professor who's teaching a class on sensation and perception this year, and that class is a standard class, but it just so happens that the professor that's teaching it this semester also has an expertise in bird song. So you should take this one now instead of next semester because it's more closely aligned with your input to your interests. Yes. Okay, so that's pretty much the end of the preamble. It's sort of a pretty long walk down a pretty short path, but I hope that's sort of clear why those distinctions were important. I hope it was not too, I hope it was useful in some way. And I also just want to make one last point before I actually, again, talk about the topic of the conversation, to go back to this original thing and say, make the point again, which that I think that it's important to have these kinds of distinctions and a good understanding of this landscape in mind as we're having this conversation. But I think just in general, in the current state of the technological landscape, it's good for us to sort of have to develop shared understanding and shared language around these types of concepts, but doubly, triply, quadruply so in the context of building AI tools for education. It's critical for us to build these tools in such a way that it clarifies and educates the stakeholders of the tool, which is the students, about how these types of things work and about how stuff is happening under the hood as they go ask it questions about what class should I take this semester, or which professor of this section would be the best fit for my interests. And that is something that I specifically don't see, one second here, with tools like GPT-4 and ChatGPT and Claude and things like that. Some of them do better and worse jobs than the other. But if you remember, we started this by realizing that the way that they use this kind of obfuscates aspects of the underlying the model definition. And there is not shared language around what we're going to call LLMs plus tools, if we're going to call them assistants, or we're going to call them something else. Like, are we going to add functions, or we add sets, which this is not really to denigrate any of the organizations that are making these things, although I'm certainly happy to do so. But it's more just to say that, like, we need to be mindful of these types of distinctions as we're building these tools. And specifically, I think the one that bothers me the most is the new O1 model that OpenAI has put out, which they call a model, but if you look at how it works and say, hey, what's a dog? The first thing it does is it does this thinking step, and it formulates an answer, and it does all this stuff. And if you recall the thing I just said, that is agentic behavior. It's doing what's called, it's a react model, reason and act. It's sort of just separate things. It's a thing that we know improves output is if instead of giving the question straight to the LLM, you feed it into an initial LLM and say, hey, what are some of the things we're going to have to know in order to answer this question effectively, and then feed it into a second LLM with the question plus that intermediate answer in order to get the final response. And so they have decided, for whatever reason, to, in the march of models that they have been sort of putting out over the past 1 or 2 years, the implementation of O1, I think, is pretty troubling, because before there was a sort of, somewhat obfuscated but fairly, I'd say, fair smoothing out of the actual model that was being used on that front-end interface. But with O1, they have broken away from that pairing and are now listing something which is clearly an agent on the same list as the models. I guess they're calling it reasoning at that point, but it's concerning to me, because I guess they're calling it reasoning on the back end. They're not calling that up here. It's concerning to me because it's a clear indication of something that we already knew, which is that companies like OpenAI or Anthropic or whoever is out there making, Google, whoever's making these big models, they are operating under a mode of thinking which is fundamentally not around that spirit that I mentioned earlier. They are not building these things in order to educate the general populace about how they work. They are building them in the standard way that the tech industry builds tools, which is to try to create an ever-increasing march of ever more performant black boxes, polished black boxes that do magical things, because it is a fundamental part of the business strategy to ensure that the people that are using the tool do not understand how it works. Because that gap between the people who rely on the tool and the ability to understand the inner workings enough to build the tool yourself is a part of their business model. And so that's why I think that it is both very important for us to keep these kinds of details and distinctions clear in our minds as we're learning how to build tools out of these types of new capacities that will fit our particular use cases. But it's also important that we build these tools in such a way that that structure is inherent to the usage of the tool, so that the stakeholders, students, the people who are actually utilizing these tools in their daily life gain an understanding of the inner workings through the standard usage of that tool. Anyways, that's an aside. Let's talk about the actual question, which is, how does SkellyBot differ from ChatGPT/GPT-4, which we can now discuss in some detail because we have an understanding of some of that distinction there. So let's talk now about the actual functionalities that the current implementation of SkellyBot embodies and the way that they are different from what ChatGPT offers. But another way to summarize basically all of that before is to basically say, don't necessarily worry too much about the current implementation of this thing. It's basically a tool that I put together over 4 iterations over 4 semesters, specifically so that I could have a tool like this that I could use and deploy in a classroom setting in order to get kind of a sense of the landscape of what it's like to use these tools in classroom settings. So it's much less about thinking about this thing as this is a thing that exists and sort of will continue to exist in this way, so much as it is as this is an example of the kind of thing that you can put together in a hurry to actually start utilizing these types of tools in an educational context. So, to get a little more specific, looking at, this is the ChatGPT main website. This is that playground space. And this is effectively what's happening there. So you have a UI on this side, and you push enter and it goes and talks to the OpenAI servers and then sort of interacts with the GPT-4o model. There you go. And you sort of get what you want to get there. In this console version, you can see a little bit more of the exposed controls. So like the system instructions are like basically like a base level blob of text that gets attached to everything. This function tab is basically those tools that I was just talking about. There's actually an example that literally is get the weather in a given location. And then all these sort of configurable aspects here. The current implementation of the SkellyBot version of this thing is the same basic idea, except using Discord basically as the easy front end. There's a couple other differences which I'll sort of talk about in a second, but behind the scenes, under the hood, basically the way this works is I built some code that runs on GCP, which is Google Cloud platform, and it's a big old pile of JavaScript and some Python code that basically interacts with the Discord API in order to kind of hijack the text boxes on the server in order to allow me to create a server where the students can talk to basically interact with GPT-4o. And then there's some interesting aspects of how it's deployed in terms of the prompts I'll talk about in a second. But the most important thing that this sort of setup does is it collects this data, this unbelievable volume and richness of text data, which is represented by the conversations that the students actually have with the AI about the thing that they care about. So I'll get to that in 1 second. But again, Jen, just speaking from that technical space, the way that this works, and sort of, I think probably the most special part about the particular implementation here is this concept of like a hierarchical prompting framework or prompting network, where basically, because also to reiterate that basically the implementation of this thing on Discord is nothing particularly special about Discord. It is very far from the right tool for the job. You can see like the use of space is really disorganized and just like it's kind of just generally clunky to use. But what it is a user interface that exists, and that I was able to basically, in the time that I had to put this together in order to use it in my classwork, sort of outside of the many other jobs I'm supposed to be doing, by writing this code in a way to interact with the Discord API, it saved me from the tremendous amount of effort that would be required to build a user interface that has this level of functionality myself. And the main thing that this does for me is it handles things like user authentication, login, like the students can just go online, download it, install it on their thing, and then just join the server and interact with it that way. And it represents also a very reliable data store that I can access from any location. So from this computer, from my phone, from that computer, like it's already set up to do that. And the only thing I had to do to interact with it in this way was write code using that Discord API. But the actual interesting value, like the business logic of the actual SkellyBot server, is relatively independent of the Discord platform. So this could just as easily be something like Slack. It could be our own custom UI. It could be a website. It could be an LMS app running on Canvas or Blackboard, something like that. It would just basically require like a different layer of interface wrapping code to allow it to communicate with the server. I got sidetracked there. So in this context here, basically this top level channel, which I discussed prior, represents the system prompt, and the nature of the software setup in Discord is such that every other conversation that happens within the server will have this system prompt attached here. So copy text, do that. So this platform back here, it's intended to be kind of like a developer sort of testing space. So it's not a the right one? Yeah, anyway, sorry. Yeah, so this sort of is a representation of like the kinds of things you can do with code when you're interacting with the OpenAI server API. So like in terms of the original question of like, what does this give you above standard GPT-4? Well, the main thing that it gives you is sort of a unified framework for interacting with students in a classroom setting. And it allows you to sidestep all the difficulties of setting up custom user interfaces and things like that, while still maintaining a framework that will store all of the data from the conversations in a centralized, reliable repository, which can be used for later analysis and things like that, which I'll talk about in a little bit. So to get through these notes here, so the main thing, so you get to tune it for however you like. It's got this hierarchical prompting framework where every conversation that happens in this server will happen within the context of this instruction set that I dictated for this class, which is basically a combination of the syllabus for the class with this sort of like instruction set about like how the bot should behave and interact and things like that. And then within the subtopics and subchannels of the server, we still haven't gotten to this part where can I see this? Yeah, I haven't really fleshed this part out. That's going to come later in the thing, but within this Discord server, I can add additional levels of prompting within each category and subcategory and channel, so that if I wanted to have more instructions about how the bot should engage with students on the topic of biomechanics, I could sort of add that here, and that would sort of be added to every conversation that happens. And this type of thing, so should I show this here? Yeah, so this is sort of what that will look like in each conversation level. So this is AI message, student message, AI message, and sort of whatever it was that they were talking about in here. And so that also gets to the secondary question of one of the advantages of this is that, well, first of all, one of the original advantages, actually, sorry, let me back up a second. One of the first things that I intended to, if I ever get time to work on this thing again, one of the first things that I would want to do is to add more configurability to this, because right now you start the chat, and from the student's perspective, that's about all the control you get. From the server manager, professor, person running it, you get to set these prompts, and you get to, this emoji sort of turns them on or off, but that's kind of static. So one of the things I would really want to do would be to add controls like this, where you can control things like, I don't think these are particularly useful controls, but you could add the ability to set different levels of prompts, sort of like remove the system prompt if they want to, and just generally add more control there. And one of the things I would and that's sort of part and parcel of the that observability and controllability aspect of things, where even if the students don't really need to interact with the bot at that level, it would be an available option. Another really important thing that we could do with definitely ChatGPT wouldn't do would be to add the ability to have as one of those sort of configurable parameters setting which LLM they are actually wanting to talk to. So in the same way that OpenAI has servers where you can talk to GPT-4 and GPT, all the GPTs, Anthropic also has servers for talking to their LLM named Claude. And it's pretty straightforward to set things up so that instead of routing the messages to and from the OpenAI servers, it can route them to and from the Anthropic Claude servers. Or you could set up to run your own local llama file, and then they could have that conversation with that bot. And the nice thing about this one is that nothing ever has to go into the server of some other company. Everything can stay local and internal and fully private, and that's always a nice thing. And so by building this bot as kind of like a crossroads things, one of the things that you can do is sort of set, as the professor, a sensible default. Say, hey, you know what? I think for our purposes, GPT-4o is the best choice. Oh, actually, for our purposes, for some, details of how like low-level details of like how these things are trained, actually, I think Claude would be better for this. And so you, as the professor or whatever, can set the defaults to a certain value, but then you can encourage them to ask the same question to different LLMs and see what the different answers are. And that could both in terms of like the flagship models, like the biggest ones, which are sort of like arguably comparable, but also to the local models that are like definitely not as capable as the big ones behind the servers, but interestingly often more specialized in their capacities. And at this point, over the course of a single semester, at least 2 or 3 of these local models will come out that will outperform the previous ones. So you can kind of get an example of how things, there's sort of the opportunity for this like passive educational aspect within whatever class you're teaching, because there's always going to be this context of sort of learning, or at least having the opportunity to learn how the different LLMs interact with the same basic instructional framework. But let's talk about LMS. I'm just going to delete the OpenAI one, not because I'm not going to use it, but just to sort of make some room and try to kill some of this complexity on the screen. So with something like an LMS, so be it Canvas or Blackboard or whoever you want to use, the basic premise of interacting would be kind of similar to how the Discord connection is currently set up, where something like Canvas will have a defined API that will basically tell you how to get certain information from their database. So you can get information, like in some of the examples I mentioned before, you might want to get information about the course information, like the available courses or the course descriptions, something about maybe the student history or the transcripts. I'm not sure if this would be LMS necessarily, but point is you can get that stuff. Department documentation about, I don't know why I pointed that to that one, but department documentation about like major requirements and, professor background information. And this information can be thrown into this spaghetti ball in the middle here and either used in one of those kind of standalone sort of examples that I mentioned before, or it could be combined with the information that's coming off of a particular course's conversation space. Again, either through a Discord or through a Slack or through an independent UI. I have never used any of those third-party applications on Canvas. I mean, I taught courses through Canvas and Blackboard for years now. But I'm certain that with those, you could make your own kind of either chat space or more of like a message board space and sort of connect that in the back end with something like the code that's currently running SkellyBot, which would provide an interface onto Anthropic or OpenAI or Mistral or Mixtral or whatever else you want to do. And so, so there's a lot of different configurations, I hope, is one of the themes that I was able to communicate. And one of the things that I really do want to focus on is that whatever these applications are and whatever kind of setups you want to do, either in terms of developing server conversations for a single course or where I get kind of excited is thinking about this as something that could persist longer than a course period. So you could be recording, prompted chats between the students and whatever configured AI thing over the course of their trajectory at their university. So getting a sense of where they are at different stages in their education, because all of these things, whatever they're happening, are going to produce data. And data in this case represents conversations between the student and the prompted AI collected over time. And I'm going to show you some examples of the kinds of data sets that I've pulled from the classes that I've taught, while of course understanding that these are all, like, none of these really made it to like full fruition because they're semester long courses. So I kind of work on them while I'm teaching the class. I sort of involve the class with the development to some extent, and then typically the semester will get to a certain point, I'll reach a certain high water mark, and then that's kind of where that gets, and we sort of start the cycle again. So this is the repo for the first iteration of this thing. github.com/johnmathis/OG_classbot, which this was used in a summer course, an online summer course in summer 2023, on the neural control of human movement, which is my actual area of research. And, it was a pretty basic boy, but it did the job. And it even got a little bit of a write-up, which is the only one I've actually written up about yet. But this is basically what the class looked like. So showing the just cumulative word count from the course of teaching the class. Just as at this point in time, I didn't really have any better capacity than that. But you can see sort of over the course of the semester, the blue is the total word count, red is the words produced by the bot, green is the word produced by the students. The course, which was, did I say how many words in there? It wasn't that many. It was a pretty small class. But they wound up producing a grand total of over 140,000 words. And the students themselves wound up writing around 50,000 words, which I think I did the math, and it comes out to like roughly like a 6 to 8 page paper of writing. And although I'm not analyzing the content of what they said, just because, I guess volume wise, I did wind up reading most of these, but I think I spent most of that semester just writing code, which is not ideal. But because of the prompting framework that it's set up, I know that every one of these conversations was on topic to some degree or another. And then this is showing the individual trajectories of each student, and you can see like these stripes are basically single conversations that they had, and some of them had, sort of did it like more close to the right way. Some of them did a ton at the beginning and then less throughout, and it's a whole thing. So that was the first incarnation. In later versions, I had, let's see, where was that one? I have too many Discord servers in my life. Despite how much I use Discord, I do not actually like it very much. So this was the second one, and you can see sort of same kind of structure where it's just like a bunch of chats that are kind of like hard to really parse. And so at the end of the class, I, throughout the class, but at the end of the class, mostly in this time, I would run some code to scrape the server and basically pull each of these conversations into a simple raw text markdown file. Oh, look at you. I taught them that. And just asking it for a list of things and saying, tell me more about a subset of those. It's like one of the little like tricks you can teach them, and it was a really good way to explore the space. And so then, again, this is not particularly, there's work to be done here, obviously, but this represents, so this is Obsidian. It's a markdown viewer, and each of these documents, I believe, represents so I'm trying to remember. I think I went through and basically pulled each of the chats from each of these. Was this the one? Was it a different one? Oh, it was this one. Yeah, it was this one. Same basic idea. but more going on. And then there was stuff more tuned towards topics. And I also had set up image generation too, which was also fun because you can basically set it up to pull like generate an image based off the content of what was being discussed, which I'm sure there's one somewhere. Yeah, so always fun. And so you can see that there's a correspondence between the titles of these documents. The number is like the ID there. And I scraped through, summarized each conversation, and then summarized the summaries of the conversations in order to, well, not summarize, but basically like smush together all the summaries. And so each of these documents is well, there wasn't that conversation in that one, but like each of this, it represents basically like the topics that were discussed in that channel. So this was in the biomechanics channel, or like the clinical channel was popular because a lot of them are pre-med. And the formatting's a little screwy. It's fine. Don't don't worry about it. But so one of the nice things that Obsidian does is it makes this graph that connects the different documents to other ones that share similar topics and tags. And you can see, again, it's not particularly well organized here. Like there's clearly a lot of these don't connect to things and stuff like that. That's the kind of thing that I would really want to work more towards. Text phrase. How am I do this? Node size, text size, server force. Yeah, so these are all the topics that were discussed. And then you can see here, there are some things that are shared between these different. So I guess each of the big balls here represents one of the channels. I think this iteration was before the hierarchical thing. Wait, was it? No, they have hierarchy. Anyways, who knows? I can't keep track. And so all of these are topics that were covered there. And again, most of them are not, it's not a very well connected graph, but there's some overlap there that just happened with even within this level of analysis. And I think over time, with more development, I really want to use that type of thing to sort of figure out what each student is talking to, and then use the topics of their conversations to connect them to each other, and then like connect them to other parts of the other parts of the class and other topics, and sort of like, oh, you're talking about like body motion capture or whatever, let's see, Parkinson's disease, I don't know, whatever, and then connect them there. Or be like, hey, you three students, you talked about this same thing here, maybe you can group up and do stuff together. Things like that. And I think one of the things I've always been dreaming about, and I'm cautiously optimistic I will get working this semester, is to have this more of a feedback cycle where like you give a lecture, you give a reading, you give some content for them to look into, and then it's a very common assignment to ask students to do like reflections, like read this article and then write a little thing about it. And historically, those are very loosely graded just because the volume is so high. But instead of doing those kind of like, simple reflections, they could have a conversation with the AI that is prompted with the content of the course, and then the AI could be pulling them deeper and sort of like helping them ask better questions, which is a thing that I really see the students kind of struggle with, and sort of anyways, and one of the reasons why having this paired with in-person meeting is so valuable, because it's easier to give them kind of like a couple of nudges in the right direction. When I've done this in an online course setting, it can just be challenging, I think, for some students, because it's such a different context, that just having a little bit of in-person time where I can just like put them in small groups and then just like help them figure out how to navigate these spaces, and then they can kind of like spin off on their own. So this is kind of extracting some of the data and pulling some interesting stuff out of it and connecting it to itself by way of these like shared backlinks. But in addition, I believe it's here. Yeah. This was the same thing, except now, and this is kind of where we get into the space of like this level of natural language processing is not actually my domain of research. So I implemented some visualization algorithms without 1,000% understanding them. But basically, in the same way that I processed the conversations in order to just pull out the topics and tags and stuff like that, I also shoved them into a vector space embedding, which I think I mentioned earlier, and then did a TSNE or principal component, some sort of dimensionality reduction to basically visualize them as a 3D space. And that's about as far as I went, but you can see that they do cluster. So the color coding here, what was it? It was, I think it's just each one is a channel. I don't think anything deeper than that happened. But you can see that all the pink ones over here were from the class about jumping, which is a task I tend to look at in my classes because it's a good case study for full body human movement. But they do tend to cluster together. And this is the one where they're describing a video. This is talking about gait and balance. And you can see that there are these kind of stripes that happen. So theoretically, in this representation, closeness is a measure of content similarity. So presumably the ones that are kind of in a line are probably from the same conversation, which obviously you could plot, but I didn't get there. And so one could imagine generating data like this both within a single class and across multiple classes and across longitudinal time, either different iterations of the same course or just a student as they navigate through their own education, and basically, and not never ever replacing the human element of teaching, but just augmenting it with this ability to add this layer of quantification to the kind of interactions that happen presently, but and they're sort of I think that a lot of the work that gets done in a university setting is just bottlenecked by the difficulty of grading and assessing of reading and assessing student work. And although I have a very, very strong belief, which we could talk about at some other time, around that no matter what happens with AI in education, we must not use AI to evaluate student performance. We must not use AI to grade student work and determine which one of them did well and which one of them did poorly. That is absolutely you will absolutely ensure bias will creep into your grading system if you do that. It's just that's not what these things are for. Everyone's going to do that. We must not do that. You must not do that. I must not do that. AI is not for grading. That's just not what. Whole other conversation. And then this was the last of. Is this the one? So this was a class that I taught that was more of a capstone thing. So the topic was more disparate. And again, text feed. Ooh. So yeah, and you could just tell this is not a very well connected graph. So this one, kebab lowercase, which is the instructions I gave the AI about how to format the tags. So that's the one that gets shared the most, which is funny. But this, you can see, these were more directly, and I think the last one I showed was, how do I actually show the files? There they are. This one is per student. So they were assigned, or rather they had these sort of hex code names. And these are the conversations that the students were having with the AI. And it was a capstone course for a biology major, so their topics were much more clinical and a lot of stuff a lot of gene therapy and peptide HLA complexes, which I don't even know what those are. Research. Parasitoid wasps for apparently. Oh, I think there was one student that was studying who chose parasitoid wasp. But this kind of thing, I think, is, despite the limitations of it. Oh yeah, they're reading. Oh, that's not how that works. I showed them how to use AI to help them basically read papers that are kind of, frankly, over their head, and BDNF, whatever that is, brain-derived neurotrophic factor. See, I don't know what that is, but apparently this student does. And yeah, and although that this, there's a lot of stuff that I think there's more work that can be done here, obviously, to get things more connected and integrated. But I think that this is a good representation of the kinds of things that could be done to gather information about students and their interests and their work and the various topics of study, and use these types of frameworks and these types of methodologies of linguistic analysis to both augment like mentorship and advising, so help steer them as they're navigating their education, and also just help within the course of a single class, and help the professor understand what the students are actually interested in, and help them extract let the students kind of engage more freely with the behavior, because the professor is not sort of constrained and required to like read all the content that they're doing, or evaluate that they're like actually they're chatting in the server, but what are they chatting about? It's like you don't have to worry about that in this case, because you know that the bot will always be down to talk with the students, always be able to find ways to interact with what they're doing, like in the context of the course, and always kind of like, it's really amazing to watch some of these conversations, how it really does a good job of connecting them to topics. AI does hallucination, it makes stuff up, it gets things wrong. In the way I teach these classes, that's a part of the experience, is teaching them to understand that these things make mistakes and learning how to navigate it. So how to ask it questions about some vague topic you don't fully understand, and then ask it for keywords that you can put into PubMed to get papers on that topic. And then when you get that paper, go grab the abstract and put it in and say, hey, what's this paper actually doing? That's the kind of thing that normally a student can tend to spend like a lot of time, like a semester or more, trying to really wrap their head around like a really dense scientific paper. And that's obviously a valuable experience. But in this context, the bot will sort of gently handhold them through however dense of material you want to throw at them, and they will be able to ask it as many questions that they want about whatever topic they want. They can ask it for more information about that and less information about that. Explain this in these terms that I understand. All of these things can kind of be tuned and tweaked and assisted by the professor from the top down, but also kind of driven by the students from the bottom up. Like in the same kind of sense of like being able to follow them over the course of their education. A particular student, like you might learn about themselves. Oh, it really benefits me to see things like listed out like that. And another student like, oh, it really benefits me to see things like explained by analogy to other topics. And that sort of prompting and instruction could hypothetically be like they could bring that with them to the class. And so the professor can provide this kind of like top-down structure of here's what the class is about. But the students can both either like automatically through some LMS tracking type of thing, or just manually by just saying it to the machine, this is the kind of things that I'm interested in. These are the things that benefit me to learn in this way, and sort of steer their conversation that way. Also, you could extract that information after the fact. After you have a viable enough data set from a given student, you could ask the bot to evaluate the conversations and say, hey, what do you think the student, what does the student get excited by? What are they not so interested in? What are some things that they still don't seem to quite grasp about this given topic? What are some things that they got super quickly and might want to do more about? What are two students that seem like they would work really well together? What are the students that tend to work well in this professor's class, and what are the types and personalities of students that work well in that professor's class? I get excited talking about this because although obviously a lot of none of the things I'm describing are like easy, but the question of like, what can we do with this is just like, it's endless. Like, what can you do with a data set of 3,000 chats representing 31,000 messages? Like, I don't know, like anything. You could do anything with it. And like, yeah, I don't know. And like, you could do it from the outside in, but you could also engage the students with their own material. You can teach them how to build one of these knowledge bases about themselves and how to tweak it to get better structure and have better prompting, and like that could just be kind of part of the educational process. And I think that what I was starting with in the earlier part of this video, which God even knows how long this is at this point, long, is just this idea that it's not about trying to build the right application. It's not about building the right app, like the Canvas coach or ChatGPT's interface, or what was the one, like Khan Academy has their own sort of interactive thing. Like, they're all interesting, but for me, at some level, they're all kind of the same thing. Like, they're all just ways of shoving text into language models and having the ability to engage with linguistic data in the way that we have historically engaged with numerical data. We can crunch those words in the same way that we crunch those numbers. And I think that if that ability is harnessed in the right way, the impacts that it could have on our society as a whole, let alone our educational system, it just feels impossible to understate. So yeah, and in terms of like next steps, piloting solutions, like easiest way to do is just to find some brave tech forward professor, preferably who wants to teach kind of like a topics course, kind of similar to the human, neural control of human movement class I've taught already. Doesn't have to be the same topic, but just kind of like a survey course. Like, that's, I think, the easiest way to integrate these things. And then we could work together. I'm happy to, you could just hop on and get the code and run it yourself if you wanted to, but I think it'd be better if we could work together, sort of, share notes, share advice, and depending on when whoever relevant party wants to do it, the existing SkellyBot works reasonably well in the Discord context, and so give me a call, I can set you up, and you could be running within 15 minutes, or if there's more time, there's always a million rounds of refactor and, shoring up the existing one, connecting it to some other user interface, like, a Slack or an LMS external app or whatever you want to do. And I think over time, really just, rather than thinking about it as like, we're going to build a thing that does a thing, think of it as it's less about building a specific thing. It's not even about like building a toolbox and like Lego pieces to sort of be able to compose different things at will, although that's I think an important part of it. But I think it's really more about exploring a new landscape, a new potential space that has opened up because of the availabilities of these new technologies and these new language models to be linguistic calculators that we can now deploy and tune and utilize to augment our ability to interact with other humans through text in any context. But I think specifically in the teaching and learning context, like teaching the students to use these tools to navigate intellectual spaces that are enticing to them but are beyond them. I think it really has the potential to like change the way that we do education, because right now we have to, by necessity, sort of like take things really slowly and sort of like hold their hands through like the beginning part and just say, trust me, I promise this gets really good, but you just have to go through these early steps because all the reasons we have to do that. I think that with these types of machines, we have the ability to do what previously would be called throwing them in the deep end, but we don't have to throw them in the deep end. They don't have to go alone. They can take this, and they can, through the assistance of a human professor, careful human mentor advisor, we can teach them to navigate these intellectual spaces using these tools in ways that was simply not possible or not feasible before these things became available. And I mean, I could talk forever about this. I kind of already have, but I think I'll just shut it off there, and just say, yeah, I hope you enjoyed the journey. I hope it was roughly on topic, and yeah, who knows? Excited for what the future may hold. All right, thank you for watching. Bye.